So today we'll be introducing a new concept in this topic, which is called limiting reagent and percent yield. So let's watch this brief video or we give you more information on it. So here you go.
This video, we're going to talk about limiting reactant, which can also be called limiting reagent. Along the way, we'll also discuss a related topic called excess reactant. Now, limiting reactant, excess reactant, this stuff all has to do with chemical reactions. But to explain it from the beginning, I actually don't want to start talking about the chemistry. I want to start talking about some analogies to cooking. We'll compare a chemical reaction to a cooking recipe. Let's say you're having some friends over for a barbecue. You want to make some cheeseburgers. All right, here's what you're going to need to make them. You're going to need a bun. You're going to need a slice of cheese, and you're going to need a piece of meat. Now, since we're comparing chemistry and cooking, we can write the recipe for this kind of like a chemical equation. All right, here it is. One bun plus one slice of cheese plus one piece of meat, put that all together, and it gives us one cheeseburger. The ingredients over here that we start with, we can think of those kind of like reactants in a chemical reaction. And the products over here, cheeseburger, what we end up with. Okay, so now we've got our recipe. To do some cooking, we got to get some more ingredients. Let's rummage around in the refrigerator, see what we can find. So here are our ingredients. And you'll notice we have different numbers of each one. This happens a lot in cooking, and it also happens a lot in chemical reactions. You often start with different amounts of each reactant. So we're talking about limiting reactant here. And a limiting reactant comes into play when we ask the question, given these different numbers of ingredients, what is the greatest number of cheeseburgers that we can make? All right, we've got 4 buns here. We got 9 slices of cheese. But if we've only got 3 pieces of meat, we can really only make 3 cheeseburgers, right? Check this out. Here's the first cheeseburger. Here's a second one. And here's the third one. And then we run out of meat and we can't make any more cheeseburgers. If this were a chemical reaction, we'd say that meat is the limiting reactant. Okay? Here's a definition for you. Limiting reactant is the first reactant that's used up in a reaction. When the limiting reactant is all used up, no more product can form and the reaction stops. So clearly, meat was the first of these ingredients that was used up as we were making the cheeseburgers. And as soon as we use it all up, no more product can form. We can't make any more cheeseburgers and the whole process has to stop, right? We call it limiting reactant because it limits how much of the product we can make, right? It doesn't matter if we have 1,000 buns or 100 slices of cheese. Once we run out of those 3 pieces of meat, we're done. We can't make any more cheeseburgers. So the total number of cheeseburgers that we can make is completely dependent on the amount of the meat, the limiting reactant that we have. So after we run out of the meat, we still have some extra ingredients left up here. And these are what we call excess reactants. Excess reactant is what is left over after the reaction stops because the limiting reactant got all used up. Okay? So we have some excess reactant. We got the bun here. We have 1 excess bun and then some more excess reactant. We have 6 pieces of cheese that are left over after the meat gets all used up. Okay, so now that we've talked about the concepts behind limiting reactant and excess reactant, let's use this information to solve some problems that are a little bit more advanced. This looks more like
So I'm going to take it from here. So we are going to look at an example where we make bread rolls. So I have written this in form of a balanced equation, cooking equation. You have 3 cups of flour with 1 cup of water gives you 5 bread rolls. So if they give you 6 cups of water and 3 cups of water, how many bread rolls can we make and which one is your limiting reactant? So that's what we will find out. So So in order to do that, we'll have to do two conversions, one beginning with the first ingredient, which is the 6 cups of flour, and then the second ingredient, which is 3 cups of water. Our goal is to find out how many bread rolls we can make, so that's going to be your ratio. So just like before, begin with what's given, use the mole ratio between flour and bread rolls. So 6 times 5 divided by 3 gives you 10 bread rolls. So I can make 10 bread rolls with 6 cups of water. If I use 3 cups of water, I make 5 bread rolls to 1 cup of water. So I make 15 bread rolls. So I make 15 bread rolls with 3 cups of water. Since I make the least with the flour, flour is my limiting reactant. That makes water the excess reactant. So that's how you find out. You make a conversion between both your ingredients, find out how much product you make. The one that gives you the least amount of product would be your limiting reactant. Now let's transfer this information into a chemical equation. So here we have a single replacement reaction where you have aluminum oxide reacting with iron to form iron oxide and aluminum. Basic questions here: reactants are aluminum oxide and iron, products are iron 3 oxide and aluminum. Now, in a question like this, you will always be given the amount of both these reactants. So if you look closely, I'm going to highlight the reactants here. So these are your reactants, and which means that's what's given. So now when we set up, you're going to do a mass to mass conversion beginning with what is given, which is your aluminum oxide, and you want to find out the product, which is iron oxide. So you begin with what's given, you set up a molar mass conversion for the grams, and then a mole ratio because I have 1 mole of iron oxide to 1 mole of aluminum oxide. And then since we're finding the grams of iron oxide, you need the molar mass of iron oxide. So let's cancel out the units so you see what we end up with. So I end up with grams of iron oxide. That's how much I make with 25.4 grams of aluminum oxide. If I take you down below, I do the same mass to mass conversion, but this time I'm converting from iron to iron oxide. So I use the mole ratio between iron and iron oxide. And then these steps are pretty much similar to the last one because I'm still finding out iron oxide. So how much iron oxide do I make with 10.2 grams of iron? I make 14.6 grams. So which one is the least? I make the least with iron, 10.2 grams of iron. So that's my limiting reactant. The other one is your excess. So we're just focusing on limiting right now. So 10.2 grams of iron, which makes the least amount of your product, is your limiting reactant. The amount produced by the limiting reactant is your theoretical yield. So 14.6 grams of iron oxide is the maximum that you can make in a reaction. So that'll be your yield. So the next concept is a very simple one. It's called the percent yield. So to find the percent yield of a reaction, you need to know an actual yield. The actual yield, this one, comes from lab. So when you do this experiment in a lab setting, whatever you make from the lab is your actual yield. The theoretical yield comes from the calculation. So the formula goes this way. Percent yield is actual over theoretical times 100. So I know that actually in the lab, I would have made 13.8 grams. So that goes on top. 14.6 grams is what I made theoretically. So that goes on the denominator times 100. So how much do I make? I make about a 95%, 94.5%. So that'll be my yield for this reaction, which is a great yield. So very simple, nothing new. You know mass to mass conversions already. The only new thing that you learned today is the one that gives you the least amount of the product between the two mass to mass setup is your limiting reactant. Connect it with the analogy that we gave you in the introduction with the burgers and with the buns and the cheese and the meat, and it'll be simple enough. That's it. So you'll be typing this in into your Google Doc, and then you're done for today. Thank you.